What's up, guys? Here we go. Chapter 2, Section 4. This is actually the second video that we're doing here. And it is on how do you use algebraic properties in geometric proofs and or examples. And this video is going to focus on just the subtraction property right here. Okay? So let's dive into it. How do we use this algebraic property of subtraction in geometric proofs? Let's do it. Okay, on to your foldable algebra to geometry properties. We've done addition properties. Now on this flap right here, we're going to put whoa, why did I get so big? I have no idea. So these right here are called these subtraction properties. Subtraction properties. So let's rock and roll, man. Let's do this. Now again, put your finger on subtraction properties and flip up everything else. I'm actually pointing to the screen. It does you no good to see me do that. So you put your finger on subtraction properties, grab hold of the rest of it, flip it all up, and let's dive in. And you're going to see there are two theorems that kind of encompass the four theorems that was addition properties. And I'll just tell you this. Listen, you guys remember addition properties, there's four of them. The subtraction, going back to algebra, is nothing more than, I'm sure you heard this in many math classes, subtraction is the same thing as adding the opposite. Why do I say that? There isn't going to be a ton different between subtraction properties and addition properties, of which you'll see. However, everything I write here in this video needs to make sure that you are writing it down in your foldable flappy so we can use it in class to master subtraction property questions. Let's do it! So draw this example into your foldable for subtraction properties, and we got this segment G-I-J-O, the whole way over G-O, go. Woo. And what we have given to you is G-J, so this whole thing here from G over here to J, why is that so big? I have no idea. From G to J is the same as I to O. So those things are exactly congruent you see right here. The question is, what do you think we could conclude if that was true? Well, again, like I did before, let's come up with an example. Let's say that GI happens to be, I don't know, 20 inches. Again, completely making it up. If GJ is 20 inches, that would make IO exactly the same because from the given information of these things being congruent, they have to be the same measure. Now, what if I take this IJ, this thing right here, and I don't know, let's say I make it something completely, I'll make it really, really small. We'll make it 5 inches. If that's 5 inches, what could you conclude about GI compared to JO? Any questions there or any ideas? Well, sure. You could actually, through subtracting 20, this whole entire thing here, 20, subtract away 5, that would make this piece right there 15 inches. And same argument, since you know that this piece is 5, the whole thing from I to O is 20, just subtract the 2, that would make this 15 inches. So just through simple subtraction in this silly example, you can see that you could easily conclude that GI would be congruent to JO. And that's a subtraction property idea. So what I've just showed you is your really kind of next theorem, and I'll pop it up here on the screen so you can write it down in your foldable. But you're going to see how I write it here as it pops up. It's actually kind of combining two different theorems, like with the addition theorems. The addition theorems, there were 4 of them. This kind of consolidates the first 2 into 1, and then consolidates the last 2 into 1, 2. So you'll see how it's written. So it goes like this. If 2 segments are congruent. Now I'll take it back. It goes like this. If a particular segment, so like this segment IJ, if a segment is subtracted from 2 congruent segments, then their differences are congruent. So you're taking one thing away from 2 other bigger things that's congruent, and you're getting smaller things that are congruent. So if I have 2 logs that are 20 inches in length, and I take and cut off exactly 5 inches, I'm going to have the same thing on either side. Not the best example, but you get the idea. So I'm getting smaller with this. And then the other one's the angle. So you can see how it's written. It says, again, if an angle is subtracted from 2 congruent angles, then the differences, meaning the smaller little angles, will be congruent. Okay? Awesome. So there's really your next theorem with subtraction properties that encompasses either segments or angles. So as a silly example, let's say that we have a bucket of water over here that has 5 gallons of water in it. Again, I'm just making it up, but let's say that there's 5 gallons of water in this. And then let's say over here they are congruent in capacity, so they have exactly 5 gallons of water in it. And I take this red Solo cup, reminds me of a song, I take this red Solo cup, and I don't care it doesn't matter how big the solo cup is. You could take a small little, tiny little cup or an enormous cup. It doesn't matter as long as it's not 5 gallons or more. And you can dip this cup in here, and if you fill that cup completely up and you dump out the water from that one, and then you take this empty cup and dip it in, fill it up completely to the top, and dump it out from there, what I'm showing you is a subtraction property. You're taking one thing, this one solo cup, from that particular 5-gallon thing and that 5-gallon thing. So what does that mean? Well, if this thing here happened to be 1 gallon, it's not. If I take and subtract 1 gallon from this 5-gallon bucket, I'd be left with 4. Same thing over here. If I take 1 gallon from this 5, I'd be left with 4. So a subtraction property would make these things equal. So I know it's a silly example, but it's the same thing whether they're segments or angles. So hopefully that helps, but let's go on to now the next theorem with subtraction properties. So let's do an angle example. So what you see here is given information, SPN, that's this entire angle right here. That is congruent to SNP, that whole entire angle right there. And yes, this should go in your foldable as well. So you might as well pause it and copy all this stuff down. And let's keep going. So we got this guy, TPM, that's this angle right here. TPM is congruent to TNP. That's this guy. Ooh, look at this. TNP. Ooh, okay. So the question is, what is my conclusion? Well, again, let's come up with a simple example. Let's say that this angle SPN happens to be 80 degrees. If these guys are congruent, that means this has to be 80 degrees as well. So this entire angle here is 80 degrees. This entire angle here is also 80 degrees. Okay, let's keep going. Let's say that this angle, TPM, which is obviously smaller than angle 80, let's say that I want that to be, I don't know, I'll make it up, let's say it's 25. Well, if this is 25, this has to be 25 because they're both congruent. So if I put this angle right there to be 25 degrees, and I put this angle right there to be 25 degrees, are there any other pairs of angles that I could conclude that's congruent? Don't know yet. Well, maybe you do, maybe you don't. But here's the scoop. What if I take this whole entire angle 80 and subtract away 25? What would that leave me with? Well, 80 subtract away 25 would leave me 55 degrees. So that means this angle right there that remains would be 55 degrees. Whoa, check this out. Same argument. If I take this bigger angle 80, subtract away this little piece, the little piece in here then would also be 55. Whoa. So what am I showing you? I'm showing you the next theorem. That says if I take two congruent angles or two congruent segments, it doesn't matter, and I subtract them away from already existing congruent things. So two smaller angles or two smaller segments, subtracting them away from two bigger segments or two bigger angles, whatever. Then it's going to leave me with smaller little things that are going to be congruent. So in this conclusion right here, you could certainly conclude that MPN would be congruent to angle, that's MPN, that's this angle, MPN, congruent to angle MNT, the good old bank. So there you go. So that is your next theorem. So let me run over and give you the example with the solo cup. So again, let's say that this bucket has 5 gallons in it, this bucket has 5 gallons in it, and I have one cup, but I can't do that. I actually need more than one cup. I'm going to need 2. So if I take this and copy it like that. So now I have 2 congruent cups. That guy right there, and this, whoa, sorry, weird, and this guy right there. If I take those things, and now I dip that into this guy, and subtract away that thing, what I'd have left then, once I dip this 2-gallon solo, it doesn't make sense, but understand the analogy, a 2-gallon solo cup into this example would leave me in this bucket 3 gallons. Now if I take a different cup, except it's exactly congruent, equal to this guy over here to the right, I'm taking the same thing away from something that's already congruent. Then I would be left with 3. So if I dip this cup in there, dip it out, boop, I take 2 gallons away, I'm left with 3. Take this guy, dip it in there, left with 3. It's the same concept as taking 2 congruent angles away from 2 congruent things, or 2 congruent segments away from 2 congruent things. It is exactly the same thing. Alright, boys and girls, here's your example. No CPQ question really, because there's no way to put this in the Google form. But you still need to do the Google form, answer the question, put any questions that you have about this subtraction property, but here's the scoop. We're going to talk about this first thing when you come into class with your pod mates. You need to write this entire proof down. So you might as well pause the video. And you need to actually fill in the reasons over here to the right for these statements that I have. And I will tell you the statements are accurate. Here's what's given. Diagram is shown. Angle 1 is already congruent to angle 2. I have the tick marks in there. Our goal that we're doing is this. We are concluding that angle 3 and angle 4, that's here and there, we're concluding that they are congruent. So I went through and said STP is a straight angle, SMN is a straight angle. So STP straight angle, SMN straight angle. And then I said they're congruent. Weird, wonder why. Oh well. And then I said angle 3 is congruent to angle 4. So apply something that you just learned in this video to conclude that angle 3 is congruent to 4. And we'll talk about this in class. We'll see you guys. Proud of you, man. Let's keep on rocking. Later.